Hello students, welcome to today's online session class. In today's lesson, we'll be looking at a very important topic in robotics. Before we begin, kindly get your books and your pens ready because this is a discussion session and we are all supposed to contribute. Very good. I believe we have our books and pens ready. Now, to start with, I have two videos that I want to share. Now, your duty is to watch these videos carefully and then share with me your opinions or your thoughts on those two videos. So let's dive right into that. Well, I have robot A and then I also have robot B here. Now, just like I said, we are to observe their actions carefully and then share our opinions on these two robots. So let's start with robot A. Well, that is that for robot A. Now let us also move to robot B and then observe its action.
Somebody's watching me, somebody's watching me, somebody's watching me. Oh.
That is good. I believe we've seen the two videos. Now the question is, what have you observed or what have you seen after watching these two videos? Kindly write your answers down. Now, let me also share my opinions and then we compare with what our answers. Now, after watching the video carefully, we will all see clearly that robot A is being able to perform an action and then robot B is not performing any action, just standing. Now the question again is that what is actually making robot A perform an action and then robot B unable to perform an action? Is that okay? So clearly robot A has something which robot B is lacking. So that is what maybe student A will say. Then student B will also say that, okay, robot A is being programmed to do that, and then robot B is also programmed not to perform any action. So in this case, which student is correct? So we could all say that they are all on the same page. But then there is actually something which is what in robot A, which is making it perform that action. And that will lead us to our topic for the day. So in today's lesson, we are going to discuss what we call sensors. Is that okay? So we look at sensors and then their classification as well. Are we together? So without much ado, let's look at our lesson objectives for the day. So by the end of this lesson, the expectation is that you and I should be able to explain what a sensor is and then their classification as well. Then differentiate between active and passive sensors, differentiate between analog and digital outputs, classify sensors correctly into 4 major categories. And then finally, we identify applications of different sensors in robotics. Hope that is clear. Let's move to the next session. But before we move to the next session, based on what I've said, can someone define or think of what a sensor is? Pick your pen and your books and write your answers down. Then after that, you compare with what we have here. Now, the question is, what is a sensor? By definition, we are saying that a sensor is a device that detects changes in the environment and convert them into signals that a robot or electronic system can understand. Is that okay? So by definition, that is what a robot is. So referring back to the 2 robots that we displayed, we could all see that those two robots are performing different actions. And especially robot A is dancing. So what is actually making it, dancing, or even perceiving or understanding the song? That means that something has been programmed in it and then making it what? To perform such an action. And that is what? A sensor. So you see how useful sensors are, right? Very good. Now, having seen the definition of sensor, let us move to the examples of sensors. Is that okay? So before we start mentioning, has someone ever come across an example or read a book and then maybe came across examples of sensors? Well, let's list them here. So in case you ever come across any, then that is an advantage for you. And for those who haven't heard of a sensor or haven't seen a sensor before, we are going to mention them as well as their images as well, so that you get familiar with them, right? Then let's see them one after the other. So the first sensor we have here is a light sensor, which is the LDR sensor. And then its image is as follows. So this is how a light sensor looks like. And then we also have another example, the thermostat. And then this is how it also looks. And then the most common one is the ultrasonic sensor. And this is it. And this is how the image also looks like. And then we also have the infrared sensor. And then this is how it also looks like. And then we have the push button. And this is how it also looks like. And lastly, we have the limit switch. And this is a limit switch. So we've been able to define what a sensor is and then list some examples of what a sensor. Kindly take note because I'll ask you one day. Now, let us ask ourselves, based on what we've discussed so far, why do we think robots need sensors? Is that okay? So the question is, why do robots need sensors? Is that okay? So kindly share with me what you think or the reason why you think robots need sensors. Okay, let me share mine and then we make comparisons. As I've said, this is a discussion session and we are all supposed to contribute. So at number one, we have detect obstacles. Yes, robots need sensors such that they will be able to detect obstacles. Is that okay? Then 2, measure temperature. Is that okay? So with the help of a sensor, robots are able to measure temperature. And then detect light levels. Is that okay? So that means that when a robot has a sensor in it, it is being able to detect light levels. And then measure distance. So moving from one place to the other. So you could see that the first video that we watched, there was a TV behind playing a song, but this robot didn't push this TV down or didn't hit the TV. It was actually calculating 8 steps. Is that okay? Why is it able to do so? It as a result of what? The sensor. Is that okay? So the robot is able to to dance to the song and then also being able to calculate a distance such that it will not cause any damage. Are we together? Very good. So the next one is to detect button presses. Is that okay? So there are instances where we have buttons we press and then a robot can actually do that. Now, without sensors, robots cannot interact effectively with their environment. So considering the 2 videos that we showed, you could see that robot A, just as I said, was dancing in a room, a song was playing, and then it was being able to interact. It was being able to follow the music, the sound, and everything. Is that okay? So that is actually telling us that it has been programmed, and then the sensor is what is causing it dance to the song without causing any damage. Are we together? Very good. Now let's move to the next session of our lesson. But before we move, do anyone has a question here? Then we take it from there. All right, let's move to the next session. Now, there are basically two ways to classify sensors. Is that okay? Now, we can classify sensor by power source and then by output signal. And then under power source, we have what we call active sensors. We also have what we call passive sensors. Then output signal, we have analog signals and then we have digital signals. Don't worry, in our subsequent slides, we are going to show images of what all this, so that you get an understanding more. Let's move to the next slide. Now, two ways to classify sensors, just as we mentioned. We have active sensors, then we have passive sensors. And then this one, the active sensors require what we call external power to function, to tend to be more complex in design, and then frequently used in robots. So meaning that they are frequently used in robots. And then these are examples of what active sensors. So the sensors that the examples that we mentioned are also categorized. Is that okay? So for active sensors, we can talk about ultrasonic sensor. If you remember, I said they are the most common one in the market. And then we also have the IR sensor. Is that okay? Also under active sensor. Then we move to the passive sensors. Then passive sensors operate without generating signals from what? External power. Is that okay? And then point two, generally simpler in structure. And then point three, often react naturally to their surroundings. Is that okay? So these are also some examples of what? A passive sensor. Take note, and then we move to the next session because I'll ask you one day. Now, just as I said, we have the analog and then digital sensors. Is that okay? So this is actually a chart, or let's say a graph, showing the differences between the analog signals and then the digital signals. Is that okay? So for the analog signals, for instance, they are what? The continuous values. When we say continuous, you could see we have the 0 volts to 1 volt to 2 volt to 3 volt to 4 volt, and then to the very last one, which is 5 volt. Is that okay? So when you consider the graph, you see that starting from 0 to what? To 5. So in continuous. Is that okay? And then for digital, they are discrete values. Is that okay? They are discrete values. So only 0 and then 1. And then the 0 stands for off, and then 1 is what? On. So on the chart or on the graph, we can see the Y and then the X axis, and then we have the 1 as what? On, and then 0 as what? Off. So mostly we use this in robotics, especially when it comes to what? Programming. Is that okay? So let's take note of that. Now, sensor classification matrix. Remember, we said we are going to look at 4 main categories of what? Sensors. And these are the main categories. 1, we have active analog, we have the passive analog, we have the active digital, and they also have the passive digital. Is that okay? So when you consider this table here, you can see the classification, we see the power, and then the output as well. So we have the active analog, and then the power is what? Active, and then the output is what? Analog. And then we also have the passive analog, the power is what? Passive, and then the output is what? Analog. And then also we have the active digital, the power is active, and then output is also what? Digital. Is that okay? And then to the last one also. So basically, these are the 4 main categories of what? Sensors. Is that okay? So any question from here, then we proceed. Very good. Now let's proceed to the next slide. Now, this is the sensor classification tree. Is that okay? So this is the simplified way of what classifying sensor. So if we want to remember them quickly, now this is a tree for you. Now if you consider the top, you see we have sensors. Then when we move down, this is the active, and then this is the passive. Now this side, the active area, we have the analog, we have the digital, we have the IR sensor, and then the ultrasonic sensor. Then when we move to this side also for the passive, we have the analog, we have the digital, and we have the LDR thermistor. Remember we mentioned this in our previous slide. And we also have what? Push button, limits, and then switch. Is that okay? So this is a summary of the classification. Is that okay? So this is the tree, and then you are supposed to know that by heart. Is that okay? All right. If there are no questions, let's proceed. Now this is the active analog. Is that okay? Just a minute. So that's active analog and then passive analog. So let us look more into them. So we've already discussed this in our previous slide. Is that okay? But then their characteristics. Is that okay? So considering the characteristics of what? Active analog sensors. 1, they require power. 2, produce continuous signals. And then 3, accuracy. Then example is the infrared distance sensor. Then we can also talk about the output example. Is that okay? And then we also have the continuous. So this is what we have here: 0.5 volts to 1.2 volts to 2.8 volts, and then to 4.6 volts. Is that okay? So these are the characteristics of what? Active analog sensor. And then also here we have what? The passive analog sensors, and then the characteristics. 1, no external power generation. 2, continuous output. And then 3, simple and what? Inexperienced. Is that okay? Sorry, inexpensive. So these are what the examples. So we have the light dependent resistor, and then we have the thermistor. Let us look at the image of what? An IR sensor. So this is the image of what? An IR sensor. Is that okay? So this is also another sensor, and that is the image. I hope we are following. Very good. Now, having seen the characteristics of the passive and then active sensors, let us move to the active digital and then passive digital sensors. So here, these are the characteristics also. So we require power, produce pulses, and then use in what? Automation. Is that okay? And then we also have, when we say automation, hope you understand what automation is, right? Very good. So there are instances where we want to build cars, we want to build smart TVs, we want to build smart remotes and all that. Very okay. So we also have examples. So we have ultrasonic sensor, that is the HCSR04, the most common one in the market. Then application obstacles, and then we have distance measurement. Then the passive digital sensors also, we look at the characteristics. We have the simple on and off operation, we have the binary output, then we have the reliable and durable. Then examples, we look at the push buttons and then the limits switch. Remember we mentioned this also in our previous slides. So definitely some of these are just linked to one another. So all you need to know is you need to know what a sensor is. That is one. You should be able to mention the categories of what sensors. You should be able to list some examples and then also some characteristics of what a sensor. Is that okay? Now, if there are no questions, we proceed to our next slide. Waiting for your questions. All right, let's proceed to our next slide, and then so this is an image of what the ultrasonic sensor before we display that. So this is the practical classification table. Remember we showed the classification too. Is that okay? So this is the practical classification table. And then if you look at them, we have the sensor, we have the power source, we have the output, and then we have what? The classification. Is that okay? This has already been discussed in our previous slide. Now these are the core components of what? Electronic sensor. Core components of what? Electronic sensor. So we have sensing elements, we have the comparator, or what we call the microcontroller IC. We also have the potentiometer. We also have power pins, into bracket VCC, and then GND. We also have output pin, and then we have status LEDs. And then here I'm supposed to include an image. Very good. So I even forgot. So this is the image of the core component. So this is our image. Okay. So take note of that. So at this juncture, we look at the summary of whatever we've discussed. Is that okay? So from the very onset, we started with the definitions and all that, but these are some key points that you need to take note of. Is that okay? So what we are all supposed to know is that sensors help robots interact with the environment. Okay, sensors are also classified by power source, output signal, three together. And we also look at the 4 categories of sensors. I hope you remember that, where we mentioned the active analog, the passive analog. We also mentioned the digital and then passive digital. Then okay, then we also look at the table, the detail table, where we have all the necessary examples. We looked at all those. And then finally, we look at the proper classification. Is that okay? So proper classification helps in what? Selecting the right sensor for robotic systems. Is that okay? So basically, that is the overview or the summary of what we have discussed. Is that okay? So we are also going to look at some review questions. So based on what we have discussed, is that okay? So we should, in case you ask, what is the difference between analog and then digital signals? What will be your answer? So this is a try work. You can try them on your own, and then later you share with me. Is that okay? So we have the difference between active and passive sensors. Classify the following. So look at them carefully, and then do the needful. We copy them down, and then work on them, and then send to me. Okay. So this is another activity. So sensor sorting exercise. So let us classify the sensors. Is that okay? So we've discussed this. We have the LDR, thermistor, ultrasonic, push button, limit. So these are all examples of sensors. So your duty is to classify them. Is that okay? And then you are allowed to work in pairs and then discuss your answers. So let us do that quickly and then share our answers. Very good. I believe by now we've written our answers down. Very good. So let's proceed. So that brings us to the end of today's lesson. In our next lesson, we will be looking at actuators. Is that okay? So on that note, if there are no further questions, we call it a day. So waiting for questions, but if there are no questions, we call it a day. But before I leave, let us try to answer ourselves as to what we've learned today. Is that okay? I believe we've learned something new, and whenever you are asked, you could produce that, right? Very good. So kindly work on the assignment and then share with me using my email. Thank you.